Year 12s. Let's get started on probability distributions. And that needs a heading, probability distributions. Okay, we're going to look at random variables. That's what this is about, random variables. And those random variables, which mean, as the title suggests, variables that are ordered randomly, can turn up randomly. Those random variables can be discrete in nature or continuous, as is often the case, as is the case with data, for instance. Discrete or continuous. Discrete, remember, is countable. Continuous is more measured. So we're going to kick off in discrete with discrete random variables. Now, with discrete random variables, we are looking at we're going to look at two types in this course. We're going to look at binomial probability distribution, and we're going to look at Poisson distribution. And in continuous, we are going to look at the normal distribution, the bell curve. Okay. So let's kick things off with discrete random variables, and discrete random variables will be our starting point. And what we are looking at here is essentially an event where the random variables, the results of the experiment, the event, whatever's taking place, the results are discrete values. So what we tend to do here is we tend to assign that discrete random variable a capital letter X, and we say that is the number of whatever. Now, in our example, X represents the discrete random variables, or the set of discrete random variables that an event can take. So if we're looking at tossing a coin 4 times, then the number of heads could be our discrete random variable, and that would be X. So in example, so I'll chop this back and write example. All right, I'm going to pause. So I just wanted to get some writing out so you weren't just watching me write. So in our example, a coin is tossed 4 times and the number of heads is recorded. So we're letting X, this random variable X, be the number of heads. Now the values that X can take on, well, we're going to put that in. We're going to put those into a table. So our values are going to be small x. So big X represents the set, small x the individual values. So the number of heads that we can achieve in 4 tosses of a coin. Well, yeah, we can have 0, we can have 1, 2, 3, 4, and we are interested in what the probability that our random variable is equal to that particular value of X. And this collection of probabilities forms our probability distribution. So what's the probability here of, change my color, of you having no heads, so they're all tails. So the probability of 4 tails will be 1 in 16. The probability of 1 head and 3 tails. So this is going to be, in this case, there are going to be 4 outcomes that work out of the 16. Go to the other end of the 4 heads will be also 1 in 16. you might notice that this is looking a little bit binomial. 2 will be 6/16, and 3 heads will be 4/16, 1, 5, 11, 15, 16, 16. There's our distribution. That's our probability distribution. So therefore, the behavior of this distribution is defined by a probability distribution function. Probability, so this behavior of the probabilities defines the probability distribution function. I'll just pause. Okay, running out of space down here on my little whiteboard, but so the behavior of this probability distribution defines what's called the probability distribution function, which is shortened to PDF. Fx being our probability distribution function is equal to the probabilities, the distribution, the collection of probabilities x equals x. It's a load of new kind of new terminology, new language, but it's essentially not a particularly new concept in that we're looking to just outline all the probabilities of all the outcomes. Now, if those outcomes are discrete, we're looking at a discrete random variable distribution, and the values in here comprise our function, which is the probability distribution function. Okay, now the sum of these values here, so our sum of our fx's have to equal 1, of course, and all our values in here have to be between 0 and 1. So nothing new about this. We are just putting it or counting it in a different language. So that's board number 1. I'm going to wipe this down. I'll pause while I do so and get the second board up. Okay, we're going to consider now some of the parameters of our distribution function. And firstly, the mean of a set, the mean of our function or our distribution is our expected value. This ex here, that's this means expected value. Now, so expected value and mean are synonymous when we're talking in terms of probability distributions. So expected value is the sum of our x by our probability that x equals x. So the sum of these products. So in this example, in our example, we can say that the expected value of x is equal to 0 by 1/16 plus the sum of 1 times 4/16 plus 2 times. So we're just multiplying each possible score by the probability of that score happening. And we are summing those products. So I might just pause while we finish these calculations. Okay, so just looking now at these calculations, just crunch these numbers out and we get an expected value of 2. We do a sense check on that. Yeah, that looks about right. 2 has the highest probability. It looks central. So that's our expected value given this distribution. Okay, how to calculate the variance? Well, the variance is sigma squared or var x, and that's calculated like so. It's the expected value of x squared. Now, the expected value of x squared is this guy. That's the sum of now our x squareds by the probability that x equals x. So this is going to be 0 times 1/16 plus 1 squared by 4/16 plus 2 squared. So these numbers in here, we square. And that gives us this value. And then we subtract the square of our expected value, which will be 4. So I'll go ahead and crunch that. Okay, our variance, so we calculate the expected value of x squared, which pops out to be 5, and so our variance is 5 and our standard deviation is the square root of 5. Two more two more measures that we want to look at, and that is mode and also median. So the mode is a fairly predictable result. Our mode is simply the value of x for which the probability distribution, the PDF has a maximum. So the value of x for which the PDF is a maximum. The value of x for which the PDF is a maximum. Now that is the value of x for which the probability distribution function is a maximum. So it's our value of x that gives us our largest probability. So in our case here, that is 6/16. So therefore, our mode is 2. Now there's just one more measure, and that's the median. And in order to find the median, I'm going to have to wipe this board down, and we're going to come up with a cumulative distribution function. And so I'll show you how that works in the next on the next board. Okay, so now to finish off, we're just going to have a look at the median and how to calculate that. Okay, so the median is the middle value. How do we calculate that in a probability sense? Well, it requires the cumulative distribution function, CDF. Now, capital Fx denotes the cumulative distribution function, where little fx was the probability distribution function. Capital Fx is the cumulative frequency distribution function, just so that you understand the difference there. So we're going to set up another table here. This time we're going to write down not the individual probabilities, but the cumulative probabilities. So 0 is 1/16. Now 1 is 4/16, so the cumulative distribution is 5/16. And you'll quickly pick up here that we're going to finish with 16/16 here. Obviously, you always need to end with 1 there. So having done our cumulative frequency, cumulative distribution function, if you remember with a normal, with a frequency distribution table, what we would do is we would do exactly this when we're doing our statistics. We would have a score and a frequency, and then we'd work out our cumulative frequencies. So if our scores went 1, 2, 3, 4, and our frequencies went 7, 8, 2, 3, we would do exactly this. 7 and 8 is 15, 17, 20. We'd run our cumulative frequencies down. We'd look at 20, we'd halve it, we'd say 10 and 11th. They're my scores in the middle. 7, 15 represents my last 2, so they're both 2s. So in this set, my median would be 2. So very, very similarly, we are going to, with our probabilities, we are going to have a look at the middle 2 scores. Now, how we do that is that we establish the first score of over 0.5. So if we just walk our way through here, we'll see that we're under 0.5 here and we're over 0.5 here, 8/16 being the halfway mark. So our x1 value, if you like, is the maximum value for which the cumulative distribution function is less than 0.5. So these are both less than 0.5, but this is the larger value. So we say that this value here is this will be my x1, and this is the first value, or the minimum value of x, for which my probability is greater than 0.5, so that is my x2. So my median in this example is 1 plus 2 divided by 2, or 1.5. Okay, there endeth the lesson. We are ready to go with questions from exercise 10B and 10C. So I'll see you on the other side.